This is Geometry, Unit 10. We're going to talk about two-dimensional and three-dimensional relationships. So we're talking about a polyhedron. It's a solid that is bounded by polygons that are enclosed in a single region of space. That would be considered a three-dimensional figure. So here is an example. Each of the sides are all polygons. So this is called a polyhedron, because it's a three-dimensional polygon. It has faces, and the faces are polygons. Faces are the sides of your shape. The edge of the polyhedron are the lines that are formed. The vertex of a polyhedron is where three or more edges meet. And the base of a polyhedron, in this case, the base is this six-sided, so it's a hexagon. And we use it to name the polyhedron. So here are polyhedra, which would be the plural version of polyhedron. To name a pyramid or a prism, use the shape of the base. So here's our example of a pyramid. Notice that the base pretty much looks like a square, so we would call this a square pyramid. Whereas this is a prism, because it does not go to a single peak. The sides are not triangles. The sides are rectangles. The shape is repeated throughout the entire shape. There were pentagons going all the way through it. So we would call this a pentagonal pyramid. No, pentagonal prism. All right. So the base of this pyramid is a polygon, which we'd probably call a square. The other faces are triangles. The two bases of the prisms are congruent polygons. They are in parallel planes. The other faces are rectangles. So that's the difference between a prism, the sides are rectangles, and a pyramid where the sides are triangles. Items that are not polyhedra. Here we have a cone and a sphere and a cylinder. Recognize that all of these resemble some sort of a circle. A circle is not made up of segments, so it is not a polygon, so these are not polyhedra. This picture is somewhat cut off, but we can grow it right back in. There it goes. This has six sides. So we call it a hexagon, and then we put the AL at the end, so hexagonal. And it goes up to a point. We have triangles on the edges for the faces, so we call it a pyramid. We have six triangles going around because it's a hexagon for the base. So we have six triangles. That would be classifying the different faces and how many there are. Now this next one that kind of looks like a brick. Determining where the base is would be all up to the person looking at it. Remember, the base is the shape that's being repeated throughout the entire figure. You could say that the bottom is being repeated all the way to the top. You could say that the front is being repeated all the way to the back, or the right side is being repeated all the way to the left. You couldn't have that much options when you look down here at this prism. There's only one shape being repeated all the way through. But in this situation, you have multiple ways that you could look at that. So this would be called a rectangular prism. It's a prism because the sides are rectangles. Right? You would have two bases. Any of the bases that you wanted. Most likely your base, you would say, is the one that it's sitting on if you have a choice. But remember, bases don't have to be the one that you're sitting on. When we look down here at this prism, the shape that's being repeated all the way through, it is not sitting on the pentagon. But the pentagon's being repeated all the way through the shape, so the pentagons are considered the bases. So this base is being repeated all the way through, all the way to the top. So it's a rectangle, the base is. Rectangular prism. The other four sides are rectangles. So you might say that the sides are four, or the faces, let's call that, are four rectangles. Here, again, this one got cut off just by a bit. It would curve through there. Okay, this would not be considered a polyhedron. This is made up of half of a cylinder and a rectangular prism. Here, our base that's being repeated all the way through the shape, we've talked about this one some already, has a pentagon, and that pentagon is being repeated all the way through. So you could say pentagonal or pentagonal. This is a prism. And the sides would be 5 rectangles. We look at the next shape and we notice the face, the shape that's being repeated throughout the entire figure. Those are circles, or at least some sort of oval, but it's probably more like a circle. This would be called a cylinder. And a cylinder is not a polyhedron. Oddly enough, a cylinder is made up of a rectangle for a side. That's one giant rectangle that's curved around, like taking a sheet of paper and coning that up so you can look through it like a telescope. It's just a rectangle that's been rolled up. Here, if you look closely, you have two sides that have the same number of tick marks, another two sides with the same number of tick marks, but notice they don't have the same tick marks as each other. So this is not a square, this is just a rectangle. So we'd call it a rectangular prism. Or actually, because the sides are made up of triangles and it goes to a point, not a prism, it's a pyramid. And it has 4 triangles for the sides. On the flip side, we'll talk about a cross-section. A cross-section is when we take a plane, not an airplane, and a solid. So if you cut a solid, what we're looking for, the cross-section, is the two-dimensional figure. I often think about it as a stamp. So here we have our sphere, and if we chop the top off, we're not looking at the three-dimensional figure, we're just looking at the stamp, at what shape would be cutting through it, and that would be a circle. Here, as long as we're parallel to the base, you can see that the plane is going to produce another pentagon. We're not talking about the three-dimensional shape, we're talking about the two-dimensional shape that is touching the plane. So if you could pick this up now, what stamp would you have? You would have a pentagon as a stamp. Now this plane is cutting through the figure, but it is not parallel to the bases. It's actually perpendicular to the bases. So it's not making circles, but it's making a rectangle. That would be the cross section. And if the plane does a cross section we'll call it parallel to the bases, you get the same shape. So in this case, it's also a pentagon. So what do you notice about the shape of a cross-section when it is parallel to the base of the solid? When the cross-section is parallel to the base, then it creates I want to say it creates a base. It's not creating a base, but it's creating the same shape as a base. It creates the shape of the base. As long as you are parallel, as we could see with the second one, it's parallel to the base, so it created a pentagon. The third one was not making circles, it was making a rectangle because it was parallel to the bases. Here we made pentagons because it was parallel to the bases. Here we have a stick, you could consider this, and a flag on that stick. If we were to spin that stick around, you could swirl it in your hand, and you would create this cylinder. Identify the three-dimensional object formed by rotating a two-dimensional object around the y-axis. Here we're supposed to rotate it around the x-axis. So if we bring it this way, then it would rotate back. We would create a cone. In this situation, taking a circle and spinning it around a pole would create a sphere. Alright, here we come back, and to name this polyhedron, we look at the shape that's being repeated throughout the entire figure. And we notice that this is a six-sided figure, so we call it a hexagon. And we put an AL at the end, hexagonal. Prism. So it's going to have six rectangles. Here we look at the number of sides that we have. We have 5 sides for the base, and it comes up to a point. So this is a pentagon. So we call it a pentagonal pyramid. And it would have 5 triangles. Now this last one, consider what this last one would be. This last one is commonly mislabeled. A lot of people name this last one a pyramid because it looks like it goes up to a point. But look at the number of sides, and that's being repeated throughout the entire shape, all the way to the edge. And then the sides are rectangles. So this is a triangular prism. It has 3 rectangles for the sides.